I want to show you one more way to figure out the formula of an ionic compound, and this way is particularly helpful for transition metals. The reason for that is transition metals will often take more than one charge. If you remember, the 4s and the 3d are very close to each other in energy, and that would be true for any s and d that are filled right there together, the 5s and the 4d and so on and so forth. So what can happen there is that those transition metals, which have electrons that are going into the d that's really close to the s that's in one energy level above it, actually can do a variety of things and find stability. So for example, they might make a charge so that the D sublevel is half full and there will be stable there. So you don't need to know too much about that at this point, but it does make it hard to predict the formula of an ionic compound by using the dot method that we looked at in the last video. So what I want you to remember is that ionic compounds are neutral. And so that means your positive charge and your negative charge have to cancel each other out. And so we're going to go through a series of examples here. So we're going to start by thinking about copper 1 plus and oxygen 2 minus. Copper loses electrons in multiples of 1 and oxygen gains electrons in multiples of 2. So if you think about it that way, then it should become obvious to you that what we need here is another copper. Because now overall we have 2 plus and oxygen is 2 minus. And so that would allow us to have a neutral charge. And so then our formula becomes Cu2O. Now if we look at this one's a little more obvious. This is lead 2 plus and oxygen 2 minus. Ionic compounds are neutral. This one's going to be neutral just with one of each of those. So that one's strictly going to be PbO. Now this one gets a little more complicated. So iron loses in multiples of 3 and oxygen gains in multiples of 2. So it probably makes sense to you that we need to think about maybe adding an oxygen first. So if we do oxygen 2 minus here, then we're at 4 minus, but we're still at just 3 plus. So then to even that out, we need to bring in more positives. So then that would be iron 3 plus, and so that would be 6 plus overall, and still at 4 minus. And so now it might seem obvious to you that we need another oxygen. So again, if we're thinking about this in terms of least common multiple, the least common multiple between 3 and 2 is 6. And 3 times 2 is 6, and 2 times 3 is 6. So finally, we're going to look at lead 4. And you might be thinking, we already did lead and it had a different charge. That's true. Remember that I said that transition metals, and actually lead is not technically a transition metal. It's under the stair step over there in that post-transition metals part of the periodic table, but it still does the same thing. So Pb4 plus and O2 minus. And so I want you to think about the least common multiple here. So lead gains in multiples of 4, oxygen loses in multiples of 2. And so the least common multiple between 4 and 2 is 4, which means we're going to have 1 lead and we're going to have 2 oxygens, like you see there. And that would be PbO2. And there you go. Now you can use this method to determine the formula of any ionic compound.